You'll see a similarity here in these guys here. We've got alcohols. And I just want to reiterate there, I said this there yesterday, I've said it a couple times. Just if you look at anything and you see an R, like on the quiz and on the test, you're going to see them all over the place. It just means a chain of carbons that I'm not really interested in. Like if you see this right here, ROH. Well, this is an organic compound. There's a number of carbons here. Could be butane, could be iso, could be benzene, could be whatever. All right. But what we're focused on here is showing you there the OH group, the hydroxyl group. But if you see an R group, it's just a chain of carbons, whatever. Okay. Have a look here. Here's water, which is a bent molecule. Okay. And it all has to do with the structure of oxygen. And oxygen there, it will have, I know I'll zoom in here. Oxygen has 2 lone pairs of electrons. 1 electron, 2 electron, 3, and 4. So there's 2 pairs of electrons up here. And electrons are negative, right? So these hydrogens, like this, should look like a linear molecule, like carbon dioxide. Carbon dioxide is linear, it's non-polar, it's flat. But you see here these 2 lone pairs of electrons that are up here that are negative, they're pushing these hydrogens down. They're the reason these hydrogens, they don't want to, hydrogen doesn't like hydrogen. They don't like, positive doesn't like positive, right? So those hydrogens are trying to get away from each other. They don't want to be close together down here. So they're trying to push up, but the oxygen is just too strong. Those electrons, those 2 lone pairs of electrons are pushing those hydrogens down, so therefore water has a bent shape. Well, if you look at this bent shape, which is what gives water its polarity, okay, this side up here is negative, this side down here is positive. You have a polar molecule, which now invokes a huge range of chemistry. Okay, you'll see there that alcohols, they have that same thing. Okay, an ether, which is some carbons and some other carbons over here separated there by this oxygen. Okay, it's bent. And phenols here, okay, benzene, aromatic ring with a hydroxyl group on it, has the same thing. So there's a specific kind of chemistry that involves around this. And that's what we're going to kind of talk about there today, okay? I alluded to this there earlier, and we are coming back to it in full strength. You'll need this there for your assignment and your quiz. Okay. Alcohols can be classified as primary, secondary, or tertiary. All right? And a primary alcohol, the definition is a hydroxyl group that attaches to a carbon that does not attach, okay, to any, it attaches to 1 carbon, only else. All right, you see there, this carbon's attached to 1. That's the definition of a primary alcohol. So if you had a pentane, and on the end carbon, you had a hydroxyl group, it would be called 1-pentanol, right? All alcohol group. That would be a primary alcohol. Here we have a secondary alcohol where the hydroxyl group attaches to a carbon that is attached to 2 other carbons. A tertiary is a hydroxyl group that is attached to a carbon that is attached to 3 other carbons. Okay? Their chemistry will be different, and I'll ask you about it. And we'll get into that there today. So a primary alcohol, alcohol attached to a carbon that is only attached to 1 other carbon. Secondary, alcohol to a carbon that's attached to 2. And tertiary, alcohol to a carbon that's attached to 3. Different types of structural formulas there for 2-butanol. Now, how you name these, it's exactly the same procedure as everything else. Okay, you find your longest carbon chain. So, and you'll see here that these are all written. Okay, this is line structure. Okay, here's your condensed structure, but they're all the same thing. I will ask you all of these three interchangeably. So you have to be able to pull these off and understand them. So even for the assignment of the quiz there, have a blank piece of paper or have some scrap paper there so that you can do some doodling. All right? Just to manipulate, because some people don't like this. Okay? So I'm going to give you a question with this. You can transform it onto your scrap piece of paper and all. Okay, so that's what he's talking about there. Know that there is 1, 2, 3, 4 carbons in here. The hydrogens are there. We're just being lazy. Okay. 2 butanol there. And another thing, I will say it again, and I'll probably say it again for the next 2 weeks. Be careful. Single bonds, like carbon to a hydrogen or carbon to another carbon, single bond, there is rotation. These things are rotating on their own axes, okay? And this hydroxyl group is right here, right? And this carbon here, which is attached to this carbon and attached to this carbon. So this carbon here has a hydrogen up here, right? It's right here. It's written in the formula, all right? So the hydrogen is here, and the hydroxyl group is only here. Not a chance. These are all single bonds. This hydroxyl group, I can write it up here. Okay, they're rotating. Everything is rotating. The only 2 ones there that are not rotating are the alkenes, double bond, and the alkynes, the trips. Those, there is no rotation. Those are locked in on a plane, like a flat piece of paper. All right, and just be careful of cis and trans. That only occurs in alkenes, not alkynes. All right, and whenever you see, how do you know if I'm looking for a cis or trans type of question? When you see an alkene written in that X style that I was talking about there last week, you'll see them there on the quiz and the assignment. Okay, that's what I'm looking for. Any issues with that, email me. We'll set up a time and we'll get you guys through it. Okay. I'm going to introduce these, but we're going to come back to them there towards the end of, I think it's week 12. Yeah, the very, very last lecture. Okay. And when we get into sugars and polyhydroxyl alcohols. Whew. These are alcohols with more than one OH group. Diols, triols, carbohydrates like D-galactose, D-glucose, these kinds of things. And you'll see there, look at all the alcohols that are on here. 1, 2, 3, 4, 5. All right. We'll get into more of these, what D means. Okay. And we'll get into that there week 12 for sure. And what we've got here now, what I wanted to show you, each hydroxyl group, okay, can be classified as primary, secondary, or tertiary. Okay, great question. I like it. What I'm asking you to do is all of the hydroxyl groups that are here, can you classify them as primary, secondary, tertiary? And you have a look here. Here I have this CH2 coming off the end. So that's why this alcohol group here is a primary. Okay, because this carbon, all right, is only attached to another one other carbon. You have a look at this alcohol group. It's attached to a carbon that's attached to one carbon and 2 carbons. So that's why this is a secondary alcohol. Why is it important? Because I'll show you there when we do oxidation of alcohols there in a couple slides. The chemistry is different. And I do ask a couple questions on that. You look at this alcohol group here. The carbon is attached. This is the carbon here. It's attached to a carbon, attached to another carbon, secondary. Same for this one, same for this one. Okay, good question, easy question, not too bad. Harley, are you? Great, my dog just puked on the floor. That's wonderful. Harley, why would you do that, man? Get out of here. So, let's have a see here. Naming alcohols, it's the same procedure. Well, no, you're just sitting beside me. Wonderful. Nah, it's not bad. You didn't need anything. So see how the following examples are named. Here we've got 1-propanol. And where do we start counting? From the side, from the shortest side, where's the alcohol? That's how this one goes. Here we have 2-propanol. And I will say it again. If you're going to put a number into your name, there had better be another number. Okay? And you see here, this is not just propanol. You have to tell me where it is here, because is it on the 1 carbon? In this case here, we can have a propanol on the 2 carbon. All right? Now, is there a 3-propanol? No. It just turns into 1-propanol. Okay? Here we've got cyclohexanol. This is not benzene. Okay? Benzene will have that circle in the middle. All right? So this is just cyclohexanol. No need for a name, or sorry, no need for a number. In this case here, have a look. 1, 2, 3, cyclohexanediol. And if you have like 2-methyl or 2-ethyl groups, or in this case here, 2 alcohol groups, you've got to put that di in. If you've got 3, you've got to put in tri. Even one that is carbon tetrachloride. Listen to that one. Carbon tetrachloride. You have a carbon with a chlorine, 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 and chlorine. Carbon has 4 bonds, right? Carbon tetrachloride. Okay, 4. What do we got here? We have 3-methyl-1-butanol. So you'll see here, there, that the alcohol trumps everything. You start from the back. How do you name this? Well, find your longest carbon chain. 1, 2, 3, 4. Okay, and that's starting from the alcohol, so that's a 1-butanol. And remember, when you're writing these, you start from the back side. Always. Even when you're, let's say I give you the name, and you're trying to decipher which diagram the name is representing, start from the back side. Always, always, always. All right, so there's your main chain. 1-butanol, 1, 2, 3. On the 3 carbon, we have a methyl. 3-methyl-1-butanol. This one here, I like it. Find your longest carbon chain. 1, 2. It's an ethane. I got 2 alcohols on here. And you've got to tell me where they are, because this could be 1,1-ethanediol. Right? So there's 2 there, so it's 1,2-ethanediol. Any issues with that, let me know. Here we've got this one. Name the following. This one here looks like a beast. It is. Don't worry about it. Okay. What's the first thing you do? Find your longest chain. Okay. And be careful. It looks like this one is the case here, but sometimes it's not. Sometimes you may have to do a snake, a python through and find your longest chain. But we got 1, 2, 3, 4, 5, 6, 7. So that's a heptane. Okay, so which side am I going to start on? Well, I got 1, 2, 3. Oh, here I got 2 methyls on the 3 carbon, but no. The alcohol trumps it. So you start numbering from this side. 1, 2, 3. Because if I started numbering from this side, 1, 2, 3, 4. 1, 2, 3, 4, 5. That would be a 5. No. So we start numbering from here. 1, 2, 3. So that is a 3-heptanol. And then you start from the back side. Okay, so we've got this one here already ready to go. Now let's move on. So 1, 2, 3, 4, 5. So on the 5 carbon, I have a methyl and a methyl. So 5,5-dimethyl 3-heptanol. And even though these are on the same carbon, you got to write 5,5. All right, you got to tell me where those methyls are, because it could be 5,4, it could be 5,6, that kind of a thing. So 5,5-dimethyl. Hopefully that's all right. Write the structure here for 2,4-dimethyl 2-hexanol. So it's the opposite. Here, okay, I gave you the diagram, asked you for the English, the IUPAC name. Here I've given you the IUPAC name. You got to choose which one it's going to be. Okay? Attack this from the same thing. Go from the back side. Why won't this let me highlight this? There we go. So we want to start with this one first. So we want 2-hexanol. All right. 1, 2, 3, 4, 5, 6. So you're a hexane. And on the 2 carbon, we have an alcohol group. So that's done. Now let's move forward onto here. On the 2 and 4 carbon, we have a methyl and a methyl. So 1, 2, there's a methyl. 3, 4, there's another methyl, and there you go. Okay? Please do these from the backside. Even week 13, when we're covering amines and amides and all these kinds of things, you're going to do the same thing. Okay? Open that up a bit. Perfect. They contain the polar hydroxyl group, which we've talked about. These guys here can undergo hydrogen bonding. Okay? Like you look at water. Water, we can drink it, we can bathe in it, we can swim in it. But if you do a backflip off a diving board in a really, really wrong way, you can paralyze yourself. Water can act like cement because of this hydrogen bonding. Okay? Increase in boiling points of alcohol compared to their alkanes. So I need more energy to get these guys boiling. So if I have a butane and a butanol, butanol will have a higher boiling point, okay, because of these OH groups, okay, because of the hydrogen bonding. And also, they'll have an increased solubility in water, okay. Alkanes, pretty much non-polar, but if you stick a OH on the end of it, now it should go into water. And you'll see here, this is a really good one there, because I like to use this there on a test, and just the reasoning behind it. Here I have these are just alkanes, so these are non-polar, just carbon and hydrogens, right? And here we have pentane, hexane, octane, decane. So I'm increasing the length of these chains, and you'll see what's going on to the boiling point. Okay, if I make the molar mass heavier, well, then I'm going to need more energy to break this stuff up, right? Well, have a look at pentane, which has a boiling point of 36 degrees, and look at 1-pentanol. Look what's going on with my boiling point just because I added an oxygen and a hydrogen on the end. Now, 1-pentanol is exhibiting all of this hydrogen bonding with water and with everything else there that's in there. And so now you need a heck of a lot more energy to get this thing boiling. And it's all because of the oxygen. Okay? List the alcohols below in order of increasing boiling point. Oh, I think there's a question on this. So we've got 1-butanol, 1-propanol, methanol, and pentanol. That should make awesome sense there to you guys. See, you are learning. Now we want increasing boiling point. Well, find your smallest and go to your largest. So methanol is 1 carbon, prop is 3, bute is 4, pent is 5. Easy peasy. If there are any questions, let me know. Okay, I'm just moving on, and if you guys have a question, please just let me know. Oxidation. There we go. Sorry. Alcohols can be oxidized, and they will form aldehydes, ketones, and carboxylic acids. Now, it all depends on whether they're a primary, a secondary, or a tertiary. So have a look here. You'll see this there on the assignment for sure, and the final exam. If we have a primary alcohol, you remember that's a hydroxyl group that's attached to a carbon that's attached to 1 carbon. And you see this right here. What it means is I'm oxidizing it. Basically, you're surrounding it with oxygen. You're giving it oxygen. And we'll use these kinds of things. Okay, potassium permanganate. Okay, these guys here. Whenever you see one of these guys here, and I'm pretty fair, but I'll let you guys know that it's oxidizing. Okay, you're adding this oxidizing agent there to it. So a primary alcohol can be oxidized. And here we're just saying, oh, it could be any of these, all right? And what will happen is, now it will turn into an aldehyde. Okay, there's your carbonyl group, sorry. All right, there's your aldehyde. It can be further oxidized into a carboxylic acid. So primary alcohols, there's a 2-step oxidation process. Step 1, converted to an aldehyde. Step 2, converted to a carboxylic acid. Secondary alcohols, okay, these are carbons that are attached to 2 other carbons. They only can be oxidized 1 step. And hopefully there, you've noticed there that with these carbonyl groups here with aldehyde and ketones, they're the same thing. An aldehyde is a ketone. A ketone is an aldehyde. But an aldehyde is only on the end of the chain. A ketone is in the middle of a chain. Same thing, same chemistry kind of, all right? But you'll see here you have the carbonyl group on the end. Here you have the carbonyl group in the middle, all right? So primaries, 2 steps. A secondary, only 1 step. And that's as far as it goes. So a secondary alcohol can be oxidized into a ketone, and then that's it. Okay? A primary will change into an aldehyde because a primary is on the end. A secondary alcohol is in the middle. So that's why you only get the ketone. And a tertiary, nada. There is no oxidizing this. So that's why we've gone into primary, secondary alcohols. All right, and their reactions there. You will see this slide again, so put a little asterisk there. You'll see it there throughout the assignment, and you'll see it on the test for sure. Okay. It's applications there of oxidizing alcohols is pretty important there. The police, law enforcement there, they use this technology there for a breathalyzer. Okay, the alcohol there coming. An application of the oxidation of alcohols is used in the breathalyzer test. Okay, the color change in the ethanol dichromate reaction. See, so basically the alcohol there is coming out of your breath, goes in the machine, oxidizes it. There we go, man. Now we can measure it. Metabolism of ethanol. Ethanol is oxidized in the liver. Okay, and yeah, when alcohol is ingested, it's quickly, absurdly absorbed there by the small intestine. Kind of the same thing as Coca-Cola or apple juice that you buy at the corner store. You know, the kind there you just pick off the shelf and pop the top. Which is more healthy, Coca-Cola or apple juice? They're both junk. And, okay, freshly squeezed apple juice is good. But the problem is, well, freshly squeezed apple juice has living nutrients in it. But the stuff there that you get at the supermarket has all been pasteurized. And what we're talking about here is the small intestine there just absorbs the alcohol, it absorbs Coca-Cola, the apple juice, because so much sugar in there, and it goes right there to your liver, okay? And your blood sugar spikes. That's how precursor there for type 2 diabetes, okay? But what goes on here is the ethanol is oxidized in the liver and produces ethanal, okay? Ethanal, there's your suffix for an aldehyde. Ethanal is toxic and can damage the liver. Excess alcohol consumption can cause cirrhosis of the liver. So here is the process there of cirrhosis of the liver, the hardening of the liver. Okay, it's this the process of converting ethanol to ethanal. Okay, that's it. Nasty stuff. And now your body's got to get rid of it, right? So ethanol is oxidized to acetic acid. So primary alcohol oxidized there to ethanal, further oxidized into carboxylic acid.
Yeah.
So hello.
Sorry to interrupt you. I just have a quick question.
Yeah, shoot away.
When you say that ethanol oxidizes to the acetaldehyde or whatever, ethanal.
Ethanal. Yeah.
Okay, is it always called ethanal?
Yeah.
Or does it depend on the alcohol?
Well, you've got naming this one here. Good question. Naming this one here, longest carbon chain, 2 carbons with an alcohol. So this would be ethanol, and it becomes oxidized. Naming this one here, 2 carbons, that's an eth, and this is your aldehyde group, so that's an ethanal. So I don't know what did you mean there, that ethanol will always oxidize into ethanal?
So like if it was methanol, it would go to methanal?
Sorry, I'm putting my thumb up. There we go.
Okay, thank you.
Propanol would be propanol. That kind of a thing. So, yeah. What goes on here? Great question. Thank you, Shaylin. In this process here of oxidation, the carbons aren't attacked or anything like this. The oxidation there is going to go right after this, the alcohol group and then terminal carbon there. And what happens is it steals one of the hydrogens, and that bond goes up here. So that's what's going on there. And the further oxidation of ethanal, it'll turn into acetic acid. That's what's going on here, okay? So this is good stuff. And as far as where you guys are going, you guys will be all over this in nursing, okay? And seeing this stuff. So it is kind of important. Acetic acid is a source of biochemical energy and thus contributes to overall caloric intake. Lots of calories in here. Lots of them. All right? So that's why consuming alcohol, it's just basically consuming table sugar. Same thing with Coca-Cola. There's not a gram of fat in a can of Coca-Cola. But if you drank Coca-Cola, 20 cans of it a day, you see it's huge amounts of sugar, which your body will just change into glycogen, and you put on some weight. What are the products when 2-butanol is oxidized and heated? So, whatever it's oxidized with, I'm not really concerned about, just as long as you guys know this is what's going on. I got 2-butanol and I'm oxidizing it. Now, this question here, I'm forcing you, okay, primary alcohol, that can go to 2 stages, right? A secondary alcohol will only go to 1 stage, all right? And a tertiary will not. So you got to realize there, 2-butanol, okay, that's a secondary alcohol. that's only going to go one step, and that'll change into butanone. And good question. Why is there no number here? Interesting. I'll leave that one. Anyone has a question for that, let me know. All right, so 2-butanol will oxidize into just butanone. Okay. Dehydration. Okay, here we have an alcohol, and we're going to suck water out of it. Okay, in an acid bath here, and what happens is water is taken out, and in the process there we have an alkene. All right. And in this process here, have a look at what we can do. We're going to, if we have two alcohols, like here, we just had one alcohol, okay, in an acid bath there, and this process here of dehydration takes the water out and forms an alkene. But if I have two different alcohols, which I have here I have ethanol and here I have ethanol, you can actually make an ether. All right, and what happens here, by the same process, dehydration, and in this acid bath, water is sucked out, and in this process here, we have now made an ether, which is an ethane group attached to an oxygen and another ethane group attached to the same oxygen. This is not the IUPAC name, but have a look at it anyway. We'll deal with it there towards the end of the PowerPoint. Diethyl ether. So a reaction in which two molecules are combined by removing a small water. There we go. Not too bad. So there's dehydration. We can make an alkene, or dehydration, we can make an ether. What ether is formed from two molecules of 2-butanol? Okay. So here I have, and this is ugly. I put this in here to show you how ugly this can get. Like, it's just, there's really not much to it. These stick diagrams. So hopefully they don't give you guys too much trouble. And then if you have any trouble, let me know. But here I have two molecules, okay, of 2-butanol. And what happened? An alcohol in an acid bath. What we have here, okay, is an ether. Okay. Welcome to your lab. The lab 5 there, esterification. And to me it was the most fun lab just for the smells. Pear and watermelon and wintergreen and yeah, the Parmesan cheese, man, that was bad. Parmesan cheese is good, but multiply that by 1,000,000. The whole lab stunk for, that's why we kind of do it at the end of term, to give it a month to kind of blow itself out. Esterification. This is where alcohols react with a carboxylic acid and they form an ester. And you'll see there, we're sucking out of water again. So here I have a carboxylic acid, C double bond O. There's your carbonyl group with an alcohol group. That's a carboxylic acid. And then plus an alcohol here. Okay, there's your OH. What happens is we suck out of water and now we have made an ester. These are the smelly ones, and it's because of these two oxygens right here. Okay. Here's acetic acid. Okay. Or we call it ethanoic acid. Carboxylic acid. We haven't covered them yet, but carboxylic acids, the suffix is oic acid. So 2 carbons, ethane, ethanoic acid, and ethanol in an acid bath. Okay, we've got ethyl acetate. All right. And if you read Lab 5 there, it tells you exactly how to name esters. We deal with it here as well, but you guys are good on that. So, 3 important reactions involving the hydroxyl functional group. We've got oxidation. primary, secondary, tertiary alcohols, right? We've got dehydration, where we can form alkenes and ethers. And we have esterification, okay? And that's where we take a carboxylic acid and an alcohol and make an ester, okay? Properties and applications of methanol. Okay, this is nasty stuff. It should never, never, never be taken internally. Okay, blindness and death. Deadly poison stuff. Boils at 65 degrees. Applications, feedstock, industrial solvent, and a denaturant there for ethanol. And you can see here, this is not going to be on your test other than some silly little question there. What are the applications of methanol? Well, then you would have to either remember if you were in a testing situation, or if you were at home in an open book exam like ours, you just have to refer to slide 24 of week 10. So even these little silly little ones, I might pull a silly question out just to see if you guys could find it. All right. Ethanol can be prepared, okay? It's kind of the opposite there of the dehydration process, right? Remember there, we had ethanol in an acid bath. It takes out a water, and we make a double bond here. Well, we can make ethanol through this process right here, okay? Properties and applications of ethanol. You'll see there that the boiling point has jumped, okay? For foodies and chefs all around the world there, they use wine in their cooking, all right? And they pour the wine into the bolognese or whatever, and you'll see there the boiling point of alcohol, ethanol, is 78 degrees. So you don't want any of that alcohol there in the food, so all that evaporates there, and on the process of boiling or making your soup or whatever, there's no alcohol left in it, okay? And here are the applications. There's lots of them there for ethanol. It's used as a solvent for organic substances, food, drugs, all these kinds of things. Okay, so have a look at those. You may be asked to recall one of them there, but they're there to begin with, okay? Here's an example of preparing 2-propanol. Well, how do we get that hydroxyl group onto the number 2 carbon? Well, right here. You have to have propene. Okay, and it's there the opposite of the dehydration. You're adding a water to it, and then this double bond breaks, and a hydroxyl group will go on the end. Another hydrogen will come up here. You may need this slide there for the assignment. This one right here. Applications of 2-propanol. Okay. Manufacture of chemicals like acetone. And you see here, 2-propanol. What kind of alcohol is it? Primary, secondary, tertiary? It is secondary. So if I oxidize it, I have now made propanone, known by its old school name that everyone will be familiar with, acetone toenail polish, or toenail polish remover. Yeah. Thank you. Ethylene glycol. You may have heard this, you may have not. It's used in a lot of things. All right? It's pretty important stuff. And ethane 1,2-diol. That's its IUPAC name. Okay, manufacture of polyester fibers, explosives, antifreeze, ethylene glycol. I even think that's used in e-cigarettes. It's one of the solvents there that houses the e-juice, that kind of a thing. Used as solvents, papers, plastic, and inks as well. Properties, okay, of glycerol, also known as glycerin. IUPAC name 1,2,3-propantriol. Okay, properties, it's a polyhydroxic alcohol. So you have a look here. this beast has 3 alcohols on it, which now will allow it to do, you could have 3 different things on here, and you see here, nitroglycerin. This stuff is very dangerous. Boom, boom, boom. Highly explosive. Okay, so there's lots of applications here. Polymers, explosives, sweeteners. Very good. Phenols. There's your benzene ring with an alcohol group on it. Okay, hydroxybenzene. But these guys here, if you check the week 9 benzene naming, this is a phenol. All right, they have their own name. Just like a benzene ring with a methyl group on top of it, that has its own name called toluene. All right, so let's have a look at this one, shall we? Naming of phenols. Have a look at these. Make them make sense. You guys are all on top of your game. You guys are all good. Make these make sense. You remember there last week there with the benzene, there's the ortho, meta, and para, right? Ortho, and then meta, and then para, all right? Down on either end. So you're looking at this. Okay, there's my benzene ring, and here I have an alcohol group, and here I have a bromine. Which is the big boss here? The alcohol trumps, okay? So this is a phenol. Okay, so now let's deal with our side groups. Okay, so this is on the 1 carbon, 2, 3. You call it 3-bromo phenol. Call it M-bromo phenol. However you like it. Okay? Here I have p-amino phenol. Para, because it's on opposite side. This is your amino phenol. Look at this one here. 2,4,6 trinitrophenol. So, and you're looking at, okay, I've got nitro groups here. I've got a hydroxyl group. Which one is going to trump everything? Because we need to start from the backside, right? So you recognize there that this is phenol, and this is the 1 carbon. So now let's start counting. 2, 3, 4, 6. 2,4,6 trinitrophenol. Okay. Here's some more practice. 2,5-dibromophenol. Okay. There's your 1 carbon. Now, be careful on your counting. You're looking at this and you're going, okay, this is my 1 carbon. So 1, 2, 3, 4, 5, 3, 6-dibromophenol. On paper, it looks good, but it's no good. You got to go with the shortest numbers. Okay. So whichever way is closest, that's the way you take. Here we have p-ethyl phenol, ethyl group, and you'll see here that we have 4-chloro-3-nitrophenol. And if I may ask, why didn't we go 3-nitro? Like, here's your phenol. So this is the 1 carbon, 2 carbon, 3, 4. Why wouldn't we say 3-nitro-4-chloro? Because we go alphabetical. C comes before N. That's why it's 4-chloro-3-nitrophenol. Okay? How we doing? We okay? Pretty boring stuff, eh? I hear ya. 3 weeks, and this will be...
Sorry, can I just have one quick question again?
Yes.
Sorry.
Who am I speaking to?
It's Shaylin.
Oh, okay, there you are. Hi. What's going on?
Hi. So I was just listening to everything you said. I just have a quick question. How do you know which one is first? Like, that's 4-chloro or whatever, so it's on like the 4th joint, if you will. But how do you know what the first one is? Is it the one with the OH?
Yeah, that's part of the trick of the game is what trumps what. And sorry, trump I'm using in the context, what is boss? That's what I need to know, because you can't get to side groups, you can't get to side chains until you've got your base, which means when you're doing these, great question, you've got to start from the back side. So you look at this beast right here. And okay, I got my benzene. All right, okay, all right. But then I got an OH here, a nitro, and a chlorine. Which one's my boss? And in this case here, your alcohol group is going to be the boss. So because the alcohol group in the benzene, it has its own name. That's called phenol. So there's your base. And whichever carbon the alcohol is on, that's your 1. So now start counting. 1, 2, 3 nitro. And you know what you do right now is over to the side of the paper, okay? 3 nitro. 4 chloro. Write that down there. And then put it all together. You've got your base, phenol, and then throw these in here and alphabetical. Talk to me, Shaylin.
Okay, so in this case, would the OH always like be the boss? Like if I didn't have the name, how would I determine which one? The boss.
That's a great question. You need to have your naming sheet there that I gave you there from week 9, because that'll tell you what will be the boss. Like there's toluene. Okay, that'll be a boss. Phenol is a boss. And you'll see there that one will trump another. One will be a boss. And so therefore, in this case here, if you see an alcohol on a benzene, that's a phenol. Take it and run. Okay? And then everything else is a side group. I'll show you with more practice. I got more stuff here. But good question. If I had a whiteboard and I had all these things there, if you guys were sitting there, I would draw you guys diagrams and all that kind of stuff. But anyway, what do we have here? Let's try these out, and we're going to build on Shaylin's question there. Some phenol derivatives are used as flavoring agents like these, okay, and some of them are in manufacturing. And you'll see here, we're not going to attempt to name these, okay? They do have names, but we're not going to... I'm just looking for general trends, okay? Like there are beasts out there with 50 carbon atoms and ethers and esters and chlorines in there, all in the mix. How do you name these? There is a style and a way to name all these things, but I'm not. I'm not taking anything too serious as far as I think the longest chain you'll ever get is a 9 or a 10, okay? And it'll be straight chain and it'll be easy. As far as alkenes and alkynes, you'll have like 1 alkene in there. All right. But there are molecules that have 5 alkenes in there. How do you name this? I'm not interested. Okay. It'll just do more damage to your learning than good. But this slide here, vanilla is a phenol. Cloves, that whole smell there with cloves. All right. That's a phenol. And here we've even got thyme. All right. It's good smelling stuff. The toxicity of phenol to microorganisms makes them an excellent antiseptic. So here we've got 4-hexyl 1,3-benzenediol. Oh, you're not going to like this one there, Shaylin, because everything I just said, these are tough. All right. So you look at this one. Here I've got my benzene. Here I've got an alcohol, and here I've got an alcohol. So, oh my goodness. This is now a benzenediol. And I apologize for the apparent discrepancy. It's just one of those things, okay? And so this one here, these two, they trump everything. So we deal with that first. That's a 1,3-benzenediol. On the 4 carbon here, we have a hexane. So 4-hexyl 1,3-benzenediol. Ugly, I know. It's just the way it is. All right, so have a look at the, please print off if you can, the have it ready to go there for test 2. Definitely have it ready there with you there for this quiz and the assignment. And what I'm talking about there is that benzene naming sheet. Okay, that's why I gave it, because it can get a little whacked. All right. What do we got here now?
I
Phenols
have a
do.
question.
Yeah, who am I speaking to?
Kaylee.
Hi, Kaylee. What do you got?
So on the last one,
Yes.
slide 35, why was it 4 hexyl?
Well, what do we got here now? If we start naming here, 1, 2, 3, 1, 2, 3, 4, 1, 2, well, okay. If we start here, so this is my 1 carbon, 2, 3, so there's your 1, 3, lowest numbers, and this would be 4. Now
Okay, I see.
that's a great question, because what if I started counting from here? Before I started counting from here, but here, okay, if I make this the 1 carbon, so 1, 2, 3, we got to go in the direction of the other hydroxyl because it's boss. So it's 1, 2, 3. So it's still 1, 3 benzenediol, but I got to keep going. 4, 5, 6. So it would be 6 hexyl, which isn't its lowest. So we'd have to go 4. Does that answer your question? How did that go?
Yeah, so you just have to go like the shortest way that basically like
That's all it
all
is.
of them then?
You just got to go to the shortest side with the shortest number, or the smallest numbers. Yeah.
Okay, thank you.
All right, good question. Thank you for asking. I love it. THC, they're found in marijuana. Okay, is a phenol. All right, and some phenols are used as pH indicators. When you're in the lab and you do a titration, I think we did their titration there for the virtual lab. The pink color that happens there when the solution changes to a base, that's because of phenolphthalein. Okay, this is an acid-base indicator. Adrenaline is a phenol. Okay, right here. Adrenaline, epinephrine, same banana. Unlike branched alcohols, phenol is a weak acid. Okay, it's not a great acid, but it's a weak acid, all right? And it has a melting point of 41 degrees Celsius. So the table below is a comparison of the pH of phenol with the pH of water. And you'll see here that normal water has a pH of about 7. Phenol itself is naturally acidic, slightly. Okay, it has a pH of 5.5. And vinegar has a pH of 2.87, about the same as Coca-Cola. And because phenol is slightly acidic, okay, it'll react with strong bases like NaOH, but it will not react with weak bases like sodium bicarbonate, baking soda. And you'll see here that phenol, weak acid, will actually react with a strong base to make this salt. Okay? And I wouldn't ask you to name any of these salts. No. Wouldn't ask you to do that. Alcohols really are not acidic. Okay, like straight chain alcohols, like here if I have like ethanol or something, they're really not acidic. So they don't react with bases, stronger bases, okay? All right, so a little bit of a trick question there. I could give you a phenol plus a strong base. What's my reaction? I could give you an alcohol plus a strong base. What's the reaction? There is no reaction. Just little things like that. We're almost done. Ethers. We're back to these guys here with a carbon chain on one side, the carbon chain on the other, separated by kind of a bridge there, single bond, to an O in the middle. Okay? And you'll remember there, this one there, I think the example was from the earlier slides there. I think it was, what was it? Diethyl ether. But if you have a look here, this is the old school name. All right? Here I have a methyl group. Here I have a methyl group. Okay, my longest chain is 1. Longest chain is 1. Ooh, I got 2 methyls here. But you'll realize there that this is an ether. So old school name, dimethyl ether. Okay. And we'll get into what's going on here. IUPAC, which is what I want you guys to focus on. On the assignment, there is, I think, a question on ISO. Write this one down. ISO means in the middle. So if you have a prop group, 3 carbons, prop, with an alcohol on the middle, okay, we would normally call that 2-propanol. You can also call it isopropanol. Iso means in the middle. So going back into here, there are some old school names there that do kind of play, and you will see them there. Okay, so don't be surprised if you see an old school name. New school, though, with ethers, it's all about the oxy. All right, to name ethers by the IUPAC system, okay, we use oxy. And you have a look here, okay, methoxy, ethoxy, phenoxy. Okay, let's try some of these out. Name the longest continuing carbon chain. So your longest carbon chain, this will be your base. And what I mean your base, you start building these names from the back forward. So here, you look at this and you're trying to name it. Okay, I got 1 carbon over here, and I got 2 carbons over here. So I got a meth and an eth. But this is an ether, so I need an oxy. So it'll be meth, oxy, ethane. Why is it not reversed? Because the last one here, that will be your longest carbon chain, whatever that is. Meth, oxy, ethane. That's how you name these. Okay. More examples. Have a look here. Here, okay, you're going to name this here. I got an eth and another eth. We saw this there, diethyl ether. But for the IUPAC name, eth, oxy, ethane. Okay. Longest chain is either of them there. You have a look at this one here. Here I have a 1, 2, 3. I have a prop group here. Here I have a 1, 2, 3, 4. Here I have a bute group here. Okay. And here I have propoxy butane. And this one here, I don't think I'd ask you something like this, because you see here there's a 1 on here, because this oxygen can attach here, it can attach here, like, you know what I mean, kind of like this. It can attach in the middle. Look at all the places there that this can attach. The oxygen, it can attach to this carbon, and it can also attach there to this carbon. So there's lots of different ways to go about this. What am I looking for? I'm looking for basic naming. These things can get crazy very quickly. That is not the intent of this course. The intent of this course is to leave you there with a knapsack full of stuff there that you can dig into and rely on in future years. I'm not here to take you guys down with incredibly ridiculous, enormous molecules. Okay? What do we got here? IUPAC names there for this one. Okay, here I've got a prop and an eth. It's an ether, so it'll be eth, oxy, propane. This one here. Here I've got a benzene ring, or maybe a phenol, or a phenyl ring. Okay, I've got a benzene, I've got an ethane here, eth, oxy, benzene. All right, have a look at these. Some of them tend to be confusing, but if you just try enough of them there, you guys do the assignment and the quiz. Please do the homework practice questions. They're awesome, actually. Okay, and the answers there. The questions are in. Hopefully, there you guys know this. The questions are in the syllabus. Okay, the answers there are at the end of this chapter. What do we got here? Properties and preparations there of ethers. Okay, they're polar enough to dissolve some polar substances like water, a little bit. Non-polar enough there to dissolve many non-polar organic. And you'll see there that their solubility depends on these carbon chains, because these carbon chains are non-polar. They don't like water. Okay? The shorter the carbon chain, the more likely it will dissolve in water. But anything past about 4 or 5 carbons, it's not really going into water because it's too hydrophobic, it's too nonpolar. Okay? And you'll see here that there is a bit of hydrogen bonding that will go on in an ether. And you see that bent structure there with the oxygen? It's got those 2 pairs of electrons up here, negative. It will slightly attract their hydrogen there from another molecule. Okay? And no hydrogen bonding there. Really between big ether molecules, because there really isn't any OH group going on here. There is a bit of an attraction there, okay, but not much. And you guys can compare the boiling points there to other, and you'll see the bigger the chain, the more boiling point, or the higher the boiling point there we need. And have a look at those. That's the PowerPoint. There's really not much. If you guys have questions, stick around. But other than that, there you guys have got lots of work to do. Have a look at the quiz. I'll open it up right now, and I'll open up the assignment right now. And keep emailing me, keep in contact, and you guys will get out of here there with the marks. Okay? Thank you, ladies and gentlemen. And stick around if you have any questions. Other than that, enjoy your day. It looks like the sun is out. Okay? Thanks, guys. Have a great one. Stick around. Cheers. And you as well. Happy Easter. Enjoy the holidays.
Good Easter weekend.
And you as well. You as well, Aaron. Be well. And I'm just going to stop recording here.